Hello everyone, today we're going to learn about recurring decimals. By the end of this lesson, you'll understand what they are and how to convert into fractions. What is recurring decimal? A recurring decimal is a decimal where a digit or a group of digits keep repeating forever. For example, we have 0.8 recurring. You will see a little dot on top of a number. That means that digit will keep repeating in that pattern forever. So we have 0.81 recurring. So this would recur in the pattern of 0.818181 forever. And the next one is 0.821. As you notice, there is no dot in the number in between those two recurring numbers, 8 and 1. That means it's going to repeat in that pattern. It's going to repeat as 0.821821821 forever. If you have 0.8221, you see there's no dots on top of the twos. It's not necessary to write the dots in every single number, so you just need to have the dot written on the first and the last recurring number. So it's going to recur in as 0.822182218221 forever. Now let's look at how to convert recurring decimals into fractions. The key idea is to use algebra to cancel out the repeating part. Let's convert 0.17 recurring into a fraction. And this number is going to repeat as 0.171717 forever. The first step is to make x equals to 0.17 recurring. Then you're going to bring the first recurring pattern before the decimal point. Now, in order to do so, you have to multiply 0.17 recurring by 100 to bring both of the repeating numbers before the decimal. And when you do so, you're going to multiply the x by 100 as well, because you're making it 100 times bigger to bring the pattern, the recurring pattern, before the decimal. Once you do that, you're going to subtract the equations so that the recurring patterns will cancel out. So we're going to set it out as x equals to 0.17 and 100x equals to 17.17. Now we're going to leave the bigger number at the top. So we're going to subtract the 100x away from x. That gives you 99x. And 17.17 take away 0.17 recurring. And as you can see, since the recurring numbers are lying on top of each other, when you subtract them, they will cancel out to become 0. So it will be 17 equals to 99, and you need to find the value of 1x. So you divide both sides by 99, and that gives you 17 over 99 equals to x. Now we have converted the 0.17 recurring as a fraction, 17 over 99. Now let's try when some digits are non-recurring before the repeating part starts. For example, here we have 0.217 recurring. As you might have noticed, that 2 does not have a dot on top. That means that number is non-recurring. But 1 and 7 has dots on the top, and they will be recurring in the pattern 0.2171717 forever. First step is to make x equals to that decimal. So it will be 0.217 recurring. Then move the non-recurring digit in front of the decimal point. Now we only have one digit that is non-recurring, and to bring that over before the decimal point, we have to times it by 10. So we're going to times both of the x as well as the number by 10, and that becomes 2.17 recurring and equals to 10x. Now we're going to bring the first recurring pattern before the decimal point. Now, in order to do so, we have to multiply it by 100. So if you multiply the 10x by 100, that gives you 1000x, and 2.17 times by 100 gives you 217.17 recurring. Now you're going to subtract the equations so the recurring pattern cancels out. Now we're going to use the 10x and the 1000x because the 10x and the 1000x have the recurring point lining on top of each other, so the recurring decimals will cancel out. So that becomes 215 equals to 990x. Now we need to find the value of 1x. So you're going to divide both sides by 990, and that gives you the fraction as 250 over 990 equals to x. Now in most of the exam questions, they will ask you to simplify the fraction. And if you simplify this further, that becomes 43 over 198 equals to x. So 0.217 recurring is same as 43 over 198. To recap, a recurring decimal is one that repeats the same pattern forever. To convert it into a fraction, we have to use algebra. We assign the decimal to x and we multiply by the powers of 10 until the recurring parts lines up, and subtract the equations to cancel out the recurring decimals, and you solve for x. This method works for both purely recurring decimals and mixed recurring decimals. Recurring decimals are just another way of writing fractions. Now that you know how to switch between them, you'll find a lot of problems much easier to solve. Thanks for listening. Please follow my TikTok, subscribe to my channel, and keep supporting